Hello and welcome to a new video from Machine Learning in Python. In today's video we're going to create a rainfall prediction model. And rainfall prediction is the application of science and technology to predict the amount of rainfall over a certain region. And it's very important to determine exactly the rainfall for effective use of water resources and pre-planning of water structures. So today we are going to use linear regression to predict the amount of rainfall. And linear regression can tell us how many inches of rainfall we can expect. The dataset that we're going to use is a public weather dataset from Austin, Texas, and it's available on Kaggle website, and I will leave the link in the description below. Let's first create our folder. We'll call it Rainfall Prediction. I'm going to use Visual Studio Code, but you can use any text editor you like. Okay, and let me bring the dataset here, which is a CSV file actually. It's called Austin_weather. And we need to do something called data cleaning here. And most of the data is very messy and unstructured. And honestly, they rarely come ready to use. And dataset, whether large or small, they always come with a variety of issues like invalid fields, missing and additional values, and so on. So in order to bring it to workable or structured form, we need to clean our data and make it ready to use. All right, as you can see here. This is all raw data. It's not structured and we need to work on that. And in our case, the data has some days where some factors weren't recorded. And the rainfall in centimeters was marked as T, as you can see here. And our algorithm requires numbers, so we can't work with alphabets popping up in our data. Therefore, we need to clean the data before applying it to our model. So let's go ahead and do that. Create a file called main.py. So this is the first thing that we will need to do, is to clean our data set. So step one is we need to import the libraries. We're going to work with pandas and NumPy. Then we want to read the data in a pandas data frame. And we will need also to drop the unnecessary columns in the data. We have columns such as date, such as events, columns such as sea level pressure high inches and low inches. We don't need all of that, so we will need to delete it or to drop these columns from the data set. I will override the data variable here. The elements inside the list are case sensitive, so be careful. Events with E capital. And let me actually copy the others. And as we mentioned before, some data here contains the T, and we need to replace all occurrences of T with 0 so that we can use the data in our model. So again, I will override data variable to replace the letter T with 0. The same thing with some dashes, which indicates 0 or none or null. And this means that data is not available, and we need to replace that with 0 as well. So let's do that. We will replace the dash by 0. And last step here is to save the data in a CSV file, which will be the final version or the clean version. We will call it Austin Final. Okay, cool. So let's run that. Perfect. So we have created Austin Final file without the T's, without the dashes, and without the date and other things that we have dropped out of the data set. All right, let's carry on. So basically we don't need this code anymore, but I will not delete it. I'll just put it in a docstring like that. So in order to continue, we will need other libraries. So we will import the scikit-learn or sklearn. And all these modules or libraries, you will need to pip install them. They don't come pre-installed in Python. They're actually third-party libraries, so you will need to pip install them. And we want from sklearn.linear_model, we want to import the linear regression. And we will import actually from the matplotlib lib.pyplot as plt. Alright, so these are the libraries that we are going to need. Okay, so now we're going to work with the Austin final file. We don't need the Austin weather anymore. This is the raw data, this is the clean data. The first thing we need to do is we need to read the clean data. So I will create another variable called data. pandas.read CSV and the name of the file. Now we're going to create the features or X values of the data, and these columns are used to train the model, and the precipitation column will serve as the label. So let's create X. This last column, we'll need to drop it. And we need the output or the label. For that, we will create a Y variable. And we want to reshape it into a 2D vector. So we'll override the Y. To -1 and 1. Now let's consider a random day in the dataset, and we shall plot a graph and we can observe this day. So let's have an index. So day index is equal to 798, and days in this case will be I for I in range the y.size, the property which is the size of the label or the output. And let's initialize a linear regression classifier. So we will call it CLF, and this will be equal to the linear regression. And here we're going to train the classifier with the output data. So CLF.fit X and Y. Okay, and I want to give a sample input to test our model. So this is a 2D vector that contains values for each column in the data or in the data set. So let's have a variable called imp, short for input, and this will be equal to the numpy.array. And what I'm going to insert here is a sample input, a random sample input. And let's override that by reshaping the input. And let's print the output. So print . Let's actually try that. Okay, perfect. So the precipitation in inches for the input is 1.33. Okay, now let's go ahead and work on our graph. So we need to plot a graph of the precipitation levels versus the total number of days. And one day, which I'm intended to put it in red color, will be tracked. So let's print the precipitation. And let's have the plot. So plt scatter, and we want the days here. We want the output with a green color. put just one day in red color. Then I will give it a title, precipitation level, and we want the X and Y label. So the X, or the horizontal axis, will be called days, and the vertical axis, or the Y label, will be called precipitation in inches. Okay, perfect. So let's show that. Let's open the terminal and run the file one more time. And there it is. You can see the precipitation level, the days from 0 to 1200, and the precipitation in inches. And this is only for Austin, Texas. And this is one day that we have chosen. So what we have done here is we have plotted a graph of the precipitation levels versus the total number of days. Okay, perfect. Let's carry on. So what I want to do next is I want to plot a graph with a few features against the precipitation or the rainfall to observe the trends. And we are going to use some of the features here. So we're going to filter like temp average F or Fahrenheit. As you know, in the United States, the temperature is measured by Fahrenheit. So we're going to filter some of this. So we will take the temperature average. We're going to take the dew point average F, this one, the sea level pressure average inches. You can do the testing on other features by filtering them as you like. So let's create a variable. I will call it x_f or features. And I will print a statement saying that precipitation versus selected attributes graph. So what I want to do now is I want to loop over these features. So I will say for I in range x_f dot columns, because they are in columns and each has a specific size. And we want to plot, actually a subplot. And this is actually the number of rows, and here is the number of columns and the index. All right. Next, I want to scatter. And I want the values in the columns with a sub I to 100. And give it a green color. Next, I want the one day, which will be in red color, the index, and let's give that a title as well. And the title here will be the X features dot each value in each column. And be careful, here the X is capital. Okay, and finally let's show the plot. Okay, so here let's put a comment. Here we wanted to plot a graph of precipitation levels versus number of days. And below here, and we're doing that to observe the different trends. All right, so let's give that a try. So it's the same. The precipitation in inches is 1.33 inch, and our graph is the same. And once we shut that, we got the second graph, which is this one right here, with the different features like temperature average in Fahrenheit, dew point average Fahrenheit, the humidity average %, the sea level pressure average inches, in inches, visibility average in miles, and the wind average meter per hour. Okay, so this was how to predict the rainfall in Austin, Texas in the USA using machine learning in Python. I hope you liked the video. Thank you for watching, and I will see you in the next videos.